In this video, I will be talking about the design of the turntable for Team White's 5-axis project from the 2023 off-season. Okay, so to start here, to provide some context, we're just going to pretend that these two pieces of stock represent the two beams that run across the drive base. So yeah, focus on the top section, I suppose. Here we have a pre-assembled turntable product that you can get from WCP. I believe it's called the Gray T turntable. It has a 7.5 inner diameter. Let me turn off selection priority. By the way, you can use selection priority to make it so you always select components. Not exactly what I want right now, because I want this line. Okay, 7.5 inch diameter. And originally this kind of turntable is used for potentially feeding some kind of ball through the center to shoot out some kind of flywheel up top. But you can adapt it to, I guess, function as the turntable for the bottom of a 5-axis arm. So that's what I wanted to do. These two pieces of stock would be the pieces that support gearbox plates for the second and third axis, potentially even the fourth axis of the arm, in terms of trying to run around everything, but we'll talk about that more in another video. For now, we're going to focus on the first axis of rotation, actually turning the turntable itself around this pivot. And we need to power it. So according to the document I went over, we already have the gear ratio worked out, if I can actually scroll here. Okay, so the 120 tube sprocket I was talking about is here, right? So that's sorted, and it's going to have the, if I remember correctly, the 16 tube sprocket running off of this final output kind of axle from the second stage of this convoluted gearbox. How this thing is meant to be used is that you have some kind of planetary gearbox, multiple stages stacked on top here, maybe the motor where my mouse is currently. You have the output axle pointing straight down, you put some kind of sprocket here, and then you run a chain around the whole thing. You have a hole here, so you can put some kind of cam to push into the planetary gearbox and shift the whole thing to the right. Originally, I intended to do something similar, except we're not using planetary gearboxes. We're going to actually use gears, like real, well, larger gears, and have a gearbox here. And the thought was to do something similar, so we can still use this hole to put some kind of cab here to shift this plate down this direction. If I can show that. So looking from top is probably more relevant. We have here these slot holes so that you can tension the chain that is going to be running around this 122 sprocket and the 16 tube sprocket here. Okay, following vaguely the path of my current mouse. So the thought was to do something like that. Now I did, if I remember correctly, I did run into some problems with this, namely this second stage of the gearbox where I have a 16th tooth gear here running into a 64, driving, I guess, a 64 tooth gear over here, meant that the distance between these two holes had to be as such. And I wanted to try to make it compact as possible, but as you can see, if I just made it go to the side out like this, I guess, hole is not very accessible. Even if I put some kind of bearing on top, there wouldn't be enough room to put a cap on this axle using the washer and bolt method. So that creates a problem because on the one hand, I could increase the length of these spacers to make this plate go lower down, but that creates a kind of standoff issue, especially since we're applying so much tension between this sprocket with the chain running around. It would also additionally create a problem of, if I move this plate any lower, I think I did calculations that the sprocket over here, the 16 tooth sprocket, would not be able to align with the sprocket. Note, if I move the plate lower, it becomes essentially the same elevation of the sprocket, and that's not acceptable. So this wasn't really panning out unless I made it look really stupid and had like the second stage go out this direction instead of to the left. And if I did that, that just creates a very long plate that's going to kind of bend downwards to the right over here. It's just not very well supported, essentially. So I thought I had to try to come up with a different way to make the gearbox part of this entire turntable. So what was potentially this other way? My first thought was that I could redesign this plate in some kind of way, making it so that it would be easier, I suppose, to put the gearbox over here. Maybe that means repositioning these holes. But to consider our current capabilities at the time, we had a broken water jet and a not very effective CNC, or at least we weren't very good at using the CNC. So I wanted to try to minimize the amount of material that we needed, both to save cost and also to put less strain on our manufacturing skills. So instead of just creating a whole entire plate or modifying this plate, but then that would mean we'd have to cut up and make the entire plate from scratch, decided I can just use this plate as is and make a small additional plate here. And I can put the slot holes where I want to put them so that everything's going to work a whole lot better for this design that we have here. So how could we modify this? Well, there's already all this junk over here, so I wanted to put it on this side, which is flat, so there's a lot of room on this side, nothing weird jutting out. To do that, we have to modify how this turntable works by elevating this entire platform slightly. If you want me to do a comparison, you can see the difference in gap between the two turntables. Notably, this red spacer here, what the heck? Okay, it should be only going till that line, and it's not all that tall. But over here, we can see that the spacer is pretty long, but this is okay because there's 8 of them. That's not going to really affect the stability of the turntable. It just makes it slightly taller, and that allows it to accommodate the Hall effect sensor so that you can align the turntable to a certain position, so then from there it would allow the programmers to better calibrate detecting which direction the whole turntable is facing. Okay, so these spacers make it so that now we can add a plate on top of the original plate. So how are we going to shape this plate? Well, general rule of thumb is you want to have at least 3 points of contact. Maybe I made it a bit excessive. You need to have some holes here to accommodate the Hall effect sensor, but I decided that considering what we were working here with this original plate, I wanted to have a number of holes. I wanted to have one decently off of the edge, off from this edge here. You can see that it's not exact, but it's approximately as long on this side as it is on that side. So the plate is only pointing out, I suppose, halfway. It just gives it, like, relatively speaking, some decent amount of stability as it's long enough on this edge, right? But the plate is triangle shaped so that it doesn't actually interfere with this circular turntable here. And we have additional holes simply because it would mean I based this on vaguely how I wanted this original plate to be attached to the piece of stock. If we look at this piece of stock, you can see that there are 1, 2, 3, 4, 5, 6, 7 rivet holes. So I just used these 2 that were originally there. Slightly excessive, probably could have done away with this hole and this hole here and just gone with 5 instead of 7, but might as well for the stability, right? And there's an additional hole here just because that's closer towards the center to provide even more attachment points Okay, so from there, we also need this plate to be designed intentionally for the positioning of the cam. So I knew that I want to put the cam in the middle of the plate so that when it pushes against the plate, it's not pushing against one edge. If I put the cam over here, right, that means that the whole plate could slant more easily. It's still kind of hard because the slot holes are so far apart, but okay, now this is talking about also the slot holes for this design. I want to make the slot holes on the outer sides of this gearbox because that provides the most amount of stability. If it's on the edges of the moving part, that provides the maximum stability possible. That's why the holes are as such for a planetary gearbox, because a planetary gearbox is only this wide over here as I'm drawing with my mouse. So now that we've talking about the supporting plate, we're going to talk about the actual gearbox here. Now, how did I first off know to make the supporting big plate this width to accommodate the gearbox? The simple answer is I didn't, at least not immediately. I did sketch it out and figure out that if I want to make the gearbox such that there is a Falcon motor and there's 2 stages of gears based on the calculations from the document, that I was going to need to make it approximately this wide. You can see that there's actually a bit of extra space, so perhaps I slightly overestimated. So how did I design this? I needed to think about layering here. So I want to make this low profile enough that the motor is not going to be jutting significantly above this piece of stock here, just as a kind of a reference for making it so that it's low enough that the first and second arm would not be able to hit this turntable motor. Obviously, if it could, that would be a potential disaster. So if I want to do that, well, logically, I have to try to make this motor as low as possible. Now, there's a limit to how low because you don't want the motor dragging against the floor. You also don't really want to just waste space by making these standoffs super long unnecessarily, if this kind of design works, and it happens to work. So what I did is I actually started with this side of the gearbox. I know that I'm going to have a 16-tooth sprocket here, as you can see, and then I'm going to have the 64-tooth gear from the second stage of the gearbox here. From there, there's going to be this 16-tooth gear here, and that leads to a few different ways to do this. I can either make the motor face downward, as you see I decided ultimately, and have the gears here. The other potential way is I could have the motor facing the other direction with the motor output axle point up here and the gears all on top. That was a potential option, and I very well could have gone with that. But I decided ultimately on this option because it's a bit more compact. You see, if these gears were on top, that would mean that this gear would potentially hit into the turntable, or there'd be some kind of funky spacing that would be required, and that would interfere with that would make it so that this whole thing would have to be a bit longer. So I could have moved this slot hole a bit further out and then just make this whole gearbox a bit longer than it is in this design, but this is more compact, and compact is better because it saves weight. It also looks neater in my opinion. So this bottom plate is actually just a rectangle outline, but by doing this and putting the gearing on the bottom side, I can make this plate have a cut in on the top, which allows me to just save a bit of space that, isn't being unnecessarily wasted with me being able to place the cam here. Now, why is the cam there and not any deeper? Simply because if it was deeper, it would run into the original plate, as you can see here. There's only so much room between the cam and this original plate. So the cam has to be there. That's as far in as it can go. And then I made it so that the plate could start as far in as possible, also make it compact so it has this kind of divot over here. In summary, that explains how I arrived to this turntable design.